Okay, welcome to Note Set M04, our fourth on MATLAB ideas. And in this set of notes, we'll be talking about indexing. So this is a pretty powerful thing within MATLAB. We've already talked about how MATLAB is all matrix oriented, so everything really can be thought of as multidimensional arrays, even beyond matrices. So matrices are two-dimensional. We could have 3 or 4 or even more dimensions, but we're going to focus here on vectors and matrices. And since we're talking about in MATLAB these different arrays, we have to have some way of indexing the elements in these arrays so that we can extract them or insert things or do things, check things about them. And so once you've mastered this is kind of the key to being a good MATLAB programmer, is to know how to go about doing indexing, getting the things out of matrices or into matrices that you want. So let's start with vector indexing. So suppose we've got some vector, we'll say x, doesn't matter if it's a row or a column vector. Either way, if we use parentheses with some integer, and that integer has to be greater than 1 because MATLAB is 1 indexed. So the first element will be indexed with 1. So it's going to extract the kth element. So these things need to be indices, or integers rather. If you try to put in something other than an integer, it won't work. They need to be positive integers. They can't be 0. So basically just starting with 1, 2, 3, 4, 5, all the way up to 6 for this. So if we create this vector, and I've kind of made the text box narrow here so this last element flows down onto the next line. If we were to say x of 2, it would go in and grab the second element of that and reply back 6. Now, I just extracted that and didn't assign it to anything, but I can assign it to something else that I want. So I could put it into some other array or rename it something or do anything else that I want with it. If I take the x of 6, now we're going to be 1, 2, 3, 4, 5, 6. That's the last element, and that will return the value 10. So it always returns the value that's in the location that's being indexed. Now there's 6 elements here. If I were to put in an 8 here, I would get a command or a warning that says index exceeds matrix dimensions. So that would happen on the command line. I think there's a little beep that happens, and it actually happens in red, even though I don't show that here. If you were to put in some other number besides 8, anything outside of 1 to 6 that's not an integer, you'll get some sort of error or warning. A nice little thing here is this end variable. So it's a built-in variable. You don't need to know how long the vector is. We could just say x of end, and it will extract the last one. So that's very handy. Although you could use the command length or size, which we talked about in a previous set of notes, to find out how long it is and use the result from that to extract the last one. But end is very convenient to use. Here I've put a transpose, so y is a column vector, and you can see that everything works exactly the same. I don't have to have any different syntax, whether it's a row or a column vector. So in those examples, I was showing just indexing one element out. We can index multiple elements out at the same time. And the way we do that is we use a vector index. So here's the vector that we're trying to index, and I can put inside the parentheses. So remember, the parentheses are the structure that we use to say, go get elements of the vector. And then I'm going to create a vector inside there. So I need square brackets to create the vector, and I just put the numbers 1, 4, 6. If you put those in there without the square brackets, it will not work. So here I am extracting 1, 4, 6. So it's going to take the first 1, 2, 3, 4, 5, 6. So it should give me back 2, 6, and 10, and in fact it does. Now here's a nice clever way to index things. Let me get rid of that here. Okay, I'm back from the phone call. So here we're using 1:2 end. Now, remember up here I said we needed the square brackets. That's to tell MATLAB that we're creating a matrix out of these numbers that we're just putting in there. When you use the colon command, you don't need to put brackets there, the square brackets. Because it sees the colon, it knows that you're creating a vector in doing that. So what is this doing? Well, remember our colon operation. So it's going to start at 1. It's going to jump every 2, and it will go out to end. So it'll start with 1, then it'll jump by 2, so it'll go to the third one. It'll skip the fourth one and go to the fifth one. And it won't actually do the end because that's not on the grid that we've defined. So we'll get the number 2, 3, and 8, and in fact that's what we get. But if we were to start at 2, now we would start with that one, and we do hit right on end on this example. So we get 6, 6, and 10. And we can jump by any amount. We can jump by 3, but now that, remember that in this case has to be an integer because what we need inside here are a bunch of integers. So, but we can jump by any amount that we want. That was indexing vectors. We can index matrices just as easily. So if A is our matrix, we extend this idea. We use parentheses. We use one integer, comma, another integer. So for example, if we were to write A4, comma 2, it's going to extract the value out of A that's in the fourth row, second column. So remember, Roman Catholic, rows and columns. So here's an example. We've got a 2-row, 4-column matrix. If I do A2, 3, I extract out the element that's in the second row, third column. If I do A1, 2, I get that. And if I put in something here that exceeds, it only has to exceed in one or both directions, I'll get the warning that will say index exceeds matrix dimensions. Now, an interesting thing is that you can also index with a single index. To be honest, I rarely, if ever, have used this, but occasionally it shows up as useful. So here's that same matrix that we had, and we're going to put in A of 1. Now, MATLAB knows that this is a matrix, but yet it looks like I'm trying to index it like a vector. So what it does is it goes down the columns. So A of 1 will give me this value back. If I do A of 2, it'll give me 5 back. Jeez. Sorry about this. All right, back from that phone call. So as I was saying, if we did 1, we'll get this. If we do 2, it goes down the column and grabs that one. If we do 3, it's now going to go back up there and get that. So basically, let me clear this stuff off. What it does is it goes in this kind of order. That's how that would work. So if we did 7, we would get this element up here. Like I said, sometimes that's useful. I've never really used it that much, to be honest. Now you can also index using 2 vectors. So we were just showing 2 slides back how to index a single element out. Just like we did when we were indexing vectors with vectors, we can index matrices with vectors. So here's our example matrix. And if I put in 1, 3, I'm asking to grab, focus on the first and third rows of that. So first row, third row, but also the first and fourth columns. So first and fourth. So the things that are at the intersections of those crisscross lines are what I'll get. And so I'll get a 2 by 2 in this case. So the dimension will be however many elements I have there by however many elements I have there. And I can use square brackets and just fill in the values, or I can not use square brackets and use the colon to get numbers there. And I can do any kind of combination that I want. So I can do 1, 2 to end and 1, 2 to end. That'll extract that. So those are some nice things. Now this is kind of cool. Suppose we would like to extract all of the columns of something. So let me clear this up here so you can see a little bit better. So suppose I want the first 2 rows, but this colon here is saying to extract all of the columns. So I don't have to put in like 1 to end there. I can just put colon. So it'll grab the first 2 rows, but all of the columns, and so that's actually what gets pulled out there. And you can also use the colon in the first element to grab all of the rows. So that's a nice handy command sometimes. Now, this colon gets used for one last thing. If we just put in no numbers and just index with just the colon, what it gives us is a column vector. And so if we start with a matrix, I didn't show what that is because by now you should be able to visualize what that thing looks like. And when you do colon, what it does is it grabs them column-wise. So it'll grab 1, then it'll grab 5 because that's the second element in the first column. Then it grabs 9. Then it gets 2 and 6 and 10 and 3 and 7 and 11 and so on. And it returns it as a column vector. And if we do that with a row vector, obviously it just spits it back as a column vector. So this is actually kind of nice in that later on when we're writing MATLAB functions, which are MATLAB programs, and we're asking for a user to put in stuff, we may be expecting the variables that we're working with, we may be expecting them to be column vectors, but the user might put it in as a row vector. So a clever thing to do is when you first bring it in, you can just do this and reassign it. So you could say x is equal to x parenthesis colon n parenthesis. And if it's a column vector already, it stays a column vector. If it's a row vector, it will convert it into a column vector. So then you know that you're working with column vectors. If what you really want are row vectors, well, convert it into a column vector and then just transpose it and you'll be all set. Now, a nice function that MATLAB has available is the find function. It's very versatile for doing indexing, and I'll illustrate its application here, but it can do a lot more than just the simple things that I show here, but this should give you an idea of how to get started. So here's an example vector, and suppose I say find x greater than 3. What that does is it gives me the index pointers to all the elements in x that are greater than 3. So that would be the 6, the 8, and the 4. And sure enough, it gives me 2, which indexes the 6. It gives me 4, which indexes the second 6. It gives me a 5, which indexes the 8 here. And it gives me a 6, which indexes the 4. So find returns an index, a set of indices, into where the elements that satisfy whatever goes into the argument. Okay, now if I want the values that satisfy that, not the pointers to them, but the actual values, I can use indexing. So remember, find itself creates indices. Now shove those created indices inside parentheses to index x, and you don't get the pointers to the values that satisfy, you get the values themselves. So that's kind of nice. And so you don't have to just use greater than. You can do any of the comparative things that we talked about before. So you can do, equal to, and so on. Greater than or equal to. Go back in the previous notes and look at all the different things that we talked about there. Now, when we're doing it with a matrix, this is one time you're forced to use the single indexing scheme for a matrix. So if you do find a greater than 6, it's going to find all the elements that are greater than 6. So let's see, we'll have the 9, we'll have the 10, we'll have the 7, the 11, the 8, and the 12. So what does it return? It returns 3, so that's 1, 2, 3, 9 is the third one, 4, 5, 6, 10 is the sixth one here, 7, 8, 9, 10, 11, and 12. So it puts into a column the scalar or the single indices into the array. And so that is one time when you're kind of forced to use that. But you can trick it. So you can also say, if you assign find to a two elements, two variables, I and j, separated by a comma. So this is actually just a way of assigning to two different variables at the same time. Now we'll have I and j will get spit out from this, and let's look at what we get. So remember, 9 was the first one, and so that's at position 3, 1. So we get 3, 1. And then 10 was the second one that was indexed, so that was at position 6, but that's at row 3, column 2, and so on. So then the 7 will be at row 2, column 3, and the 11 will be at row 3, column 3, and so on and so on. So the order that these things come out in as pairs still follows this structure that we would have for the single index scheme, but at least we have pointers into, two index pointers into where these elements are. Another very useful thing that we often need to do is find either the minimum element in an array or the maximum element in an array. And so the min and max are commands that help us do that. So I'm only going to illustrate max. Variations for min are obvious. So if you type help max, it comes back and it says max largest component. And then, as is common with MATLAB commands, it behaves a little differently depending on whether you're shoving a vector into it or a matrix into it, or a higher dimension array, which I'm not going to talk about here yet. So for vectors, so if you take max of x and x is a vector, it will return the largest element in x. And we'll see in just a bit how we can find out where that largest element actually occurred. For matrices, so now we're saying suppose x is not a vector but is a matrix. It's going to return a row vector that contains the maximum element from each column. And we'll see an example in just a second of how that works. And then this is a more general version. If we call max and assign it to two different variables, the first one actually gives us the maximums, and the second one will give us indices. And so let's see how that works. So here's a vector case. So if we call it using this more general form, which to be honest, that's the form I almost always find myself using. So here's our vector. There's the maximum. Its value is 8, and it's in the 1, 2, 3, 4, 5th position. So M, the first thing I put here, I don't have to put M and I can put anything there, but whatever it is, the first one that I put there will have the maximum value put into it, and whatever I have as the second position will have the index of that maximum value. Now here we're going to look at the case where we're indexing, or we're trying to find the maximum of an array. And so here we have our array, and we can see there is our maximum value. You'd think that it would extract that, but in fact it doesn't. Remember, it extracts the maximum element from each column, and it returns a row vector. So basically it's going to go down this column and say 4 is the biggest. Down this column 7 is the biggest. Down this column 5 is the biggest. And down this column 9 is the biggest. And so what it will do is in M, it'll give us this row vector that it's talking about. So there are the maximum values. 4 is the biggest in the first column, 7 in the second column, 5 in the third column, and 9 in the fourth column. And then the index, what does that tell you? It tells you where in the column it occurs, right? So this is for the first column, and it's telling you that the max occurs in the first row. And then this also occurs in the first row of the second column, and then the 5 occurs in the third row of the third column, and then the 9 as a maximum occurs in the first row of the last column. Now, I will leave it to you as an exercise. I would encourage you to try this. Try to figure out how to use two max calls. You can put them on separate lines if you want, to try to really extract the true maximum value. So what you would want is to pull out of here the value 9, and you'd like the index of 1, 4 to come out as well. So you should be able to figure out how to pull that out of this. And I'll give you a hint. Running this command is the first step. And then you work with these results to try to find what you need. And notice that you already get, you've got a pointer to the row where this occurs. Now you just need to find out where along this row the biggest one of all those occurs. And you'll have it. Okay, so that's using find and min and max, and there may be a few other things that are in that league, but again, as I've said, one of the best ways to learn MATLAB is to just go poke around. Poke around in the help where you see the commands find and min and max, and see if there's other things like that. So we've been talking about numerical indexing, where the things that we put inside the parentheses here were numbers that were the locations. But this is logical indexing, where the things that we'll put in here inside the parentheses will take on values of 0 and 1. Now, earlier I just got done telling you that we can't put a 0 in there. Well, I kind of lied. We can put a 0 in there when it's a logical 0. So if you put a 0 in there and its data type is not logical, it will yell at you. It'll give you an error. Yes, I was wondering if that was going to come up. Let's see. All right, there we go. Lots of interruptions in this video here. And there's my dog right on cue. So here's our vector, and so first, just reminding you of logical command, x greater than 3 returns a logical vector that gives zeros where it is not satisfied and gives ones where it is satisfied. So remember, this result is a logical vector. If you did a whose command at this point, you'd see the answer has logical type. So then if we use that, as our index, it will actually work. So we index x with this logical command, and what does it extract? It extracts all the elements that are where the condition is satisfied. So that's kind of useful. Now, compare that to what we did with find, because we did a similar thing. Notice that when we just do x greater than 3, we get the logical results back. When we do find x greater than 3, we get the indices back. So we can do this either way. We get the exact same result, and sometimes it'll be convenient to do it one way, and sometimes it'll be convenient to do it the other way. Now there's a few other commands that are return logical results that are kind of useful. These are just a few of them. There are other ones. So there's this command isNaN, there's isInf, and isFinite. And so there's other ones like isReal, I think is actually a command if I remember right. So you can check these things. Like I said, digging in and discovering things on your own is really the best way to learn MATLAB. So remember, NaN was what we used for not a number, which we get when we have like 0 divided by 0. If we have something non-zero divided by 0, we get an infinite value. And sometimes we want to check to see whether we have such results. Because if we proceed further with those things in our data, it may not give us the kinds of results that we really want. So we often want to parse these things out and remove them. So we can either check to see if we have either of those cases, NaN or inf, or we could do it the other way, check to see which ones are finite. IsFinite will give us a 0 for either NaN or infinite. So here's a way to use that. So suppose I ended up, here I am just typing it in, but suppose I got that result from some computation, and subsequent computations will not give me the result I want if they include NaN and inf. So I can extract those out. So I can use the command isFiniteX, and I do it explicitly here so that I can see what the logical result is. So remember, this is a logical variable, so I can index with that. And so you see that I get a 0 and a 0 where I get a NaN or an inf. So if I put isFiniteX inside indexing x, it's going to extract out only the ones that are not NaN or infinite. So I'll get back just the numbered values. And that's a really nice command. And like I said, there are other ones that you can use that are similar to this. So we've been talking about pulling things out of matrices. We'd like to put things into matrices sometimes. And indexing can be used to do that. But when we're pulling stuff out, usually the indexing happens on the right side of an assignment to something else. So let me back up here. I haven't really ever assigned anything here, but I could say, y is equal to x indexed by that. So notice that the indexing is on the right side of the assignment when I'm trying to extract stuff. But here, when I want to put stuff in, the indexing will occur on the left side of the assignment. So here's an assignment. I'm trying to assign 100 to something. So here's my original array, which you should be able to visualize. And in the first row, second column, I want to stuff in 100. So this is a one element location, so I can only put a single number in, and so there it is. If I tried to put something other, like a vector or another array into that one location, there would be an error. But if I do want to stuff an array in, so here I've got a 2 by 2 matrix that I want to stick in someplace, and where do I want to put it? Well, I want to put it in the location 1, 3 for the rows and 1, 4 for the column. So I've already reassigned the 100 here, so that's going to stay. But what I'm doing is first row, third row, I should extend that out, first column, fourth column. So the 1, the 9, the 4, and the 12, those 4 numbers as an array will get replaced by this array. So sure enough, there's the 200, there's the 400, there's the 300 and the 500. So remember the structure. This is the first row, this is the second row. That's why the 200 and the 300 are in the first row there, and so on. I can also use the colon to replace an entire row. So remember, I've already got these numbers in here, so those will, the 400 and 500 stuff will stay there. Those will stay the same. I'm trying to completely replace the first row, and it's going to get replaced by 1, 2, 3, 4. So that's kind of nice. So that colon operator can be extremely useful for replacing entire rows, but it can also be used to replace an entire column. You would put the colon over in the first location. Now here's an interesting thing. Suppose I index an array, but I assign a single number into that array. So technically there's 4 numbers being indexed here, 4 positions being indexed here. But since I only put a single number here, MATLAB has something called expanding. It will expand a scalar out to the appropriate size. So it'll put 55 in all 4 locations. So that's kind of handy as well. So this is kind of interesting. In fact, I didn't even know this. I learned it while I was reading through the book, preparing this lecture. I didn't know this would do this. And this is kind of handy sometimes. So unlike extraction, when we're trying to extract a number, if you exceed the indices, the range of the indices, MATLAB will give you a warning. But with assigning, it doesn't. Now, that's a double-edged sword. It's kind of nice because it allows you to kind of incrementally build, make a vector or array bigger if you want. But it's also dangerous because if you have miscalculated a pointer to where you want to put something and now you're pointing outside of the existing array, you're going to be growing that matrix bigger and you might not even know it. So just be very careful. And when you're trying to debug, you got to remember all these things. Debugging is challenging. You have to think like the machine is thinking. So here's our original vector. And so there's 4 elements, but if I say x of 5 is equal to 7, look what it does. It takes the original vector and tacks on a 7 at the end. I didn't know that it could do that. But here's something even more miraculous. So now I've got a 5-element vector, and suppose I don't go to 6, I don't even go to 7, I go all the way out to 8 and I stuff in a 10. It'll put the 10 in the 8th position and it will fill in zeros. So that's kind of cool. Zeros will be filled in. And what about if we do this for a matrix? So here's a simple 2x2 matrix. If I say, well, A34 is equal to 10, well, notice that 3 exceeds the number of rows and 4 exceeds the number of columns. And so it'll tack on all these extra zeros here to take us out to the position where we can actually put a 10 there. And that's really cool. Okay, so the last thing that we have to talk about in this set of notes is another thing I didn't actually know about, and that's indexing with empty vectors. So we defined the concept of an empty vector in a previous set of notes, and this is a pretty cool use of those. We can use it to remove parts of an existing array. So here's an example. So here's how it can be used with a vector. So I've got this vector that's got 5 elements in it, the integers 4 through 8. And if I do an insertion indexing 2 to 3, and then I assign that the empty vector, it just gets rid of them. So the 5 and the 6, which are the 2, 3 elements, are gone, and I'm left with the 4, the 7, and the 8. So that's pretty cool. So that's how it works for empty vector indexing of a vector. It's a little trickier, but not too bad when you get to the matrix case. So here we've got our matrix, and first I'm showing what we cannot do. What we cannot do is remove a single element. So I can't insertion index a single position and assign an element there, because what would happen? So here I just collapse the vector, but what would happen if I removed this? How do I readjust the rest of these? There's no way I can do that. But what I can do, using the colon indexing, I can insertion index an entire row or an entire column. So in this case, I'm insertion indexing the entire second row. So second row, all columns. So this row is now marked for elimination because I've assigned an empty vector to it. So it's gone, and I'm left with the first and third rows. So that is actually pretty cool. And so that ends our coverage here of indexing, and we'll see you in the next set of notes.